When we think about how stress and trauma impact the brain, I like to talk about a hand model that starts to describe the different levels of the brain and what happens in each part when we encounter stress or trauma. This model was developed by a researcher named Dan Siegel. And so we know the brain is more complex than this, but this is a great way to simplify to understand what's happening. So if this is our brain and our body, the arm is our body and our spinal cord. So information is moving from the body to the brain and brain to the body all the time. It's like a superhighway. There's signals always firing. We might not always pay attention to the signals, but the signals are moving nonetheless. The base of the hand is the brainstem. So this is our fight, flight, freeze response. This is our survival mode. Some people call it reptilian brain. It's one of the oldest parts of our brain, and we share it with a lot of other animals. So survival's down here. Then the palm of the hand is called our limbic system. This is our emotional brain. So say we're triggered and we slam the door, we say something we don't mean. This might be where we're operating from. This is also where positive emotions happen and where we process our sensory information is in this part of the brain. The thumb is our amygdala. The amygdala is these two almond-shaped pieces that actually are within the limbic system. And Dr. Bessel van der Kolk calls the amygdala the smoke detector. And the smoke detector, or the amygdala, is firing off alarms and stress signals anytime that we feel like there's a stress or a threat or a perceived stress or threat that's happening. And we are a better safe than sorry system. And so a lot of us have a really sensitive and very active amygdalas. So survival, emotional, right? Smoke detectors within that. And then the fingers are our prefrontal cortex. So this is our part of our brain that is responsible for reasoning and problem solving, impulse control, like I'm not going to slam the door, self-regulation, meaning both bodily regulation and emotional regulation, logic, math, these human functions, right? So we call this more of our human brain. So ideally, we're operating in the world where our brains look like this, right? And our lids are on and we're problem solving and we're logical and we're regulating ourselves and we're controlling our impulses. But life happens, right? And eventually there's triggers that start to happen and our amygdala starts to fire. You'll notice my hand starting to vibrate, right? The amygdala is firing, it's sending off these signals. One more thing happens and we flip our lid, right? And we either will jump down into this emotional brain or we'll jump down into this survival part of the brain. And it's not a conscious choice. We're not like, I'm going to freeze now, right? It instinctively happens and then we make sense of what happens after. And when you think about how our brains develop, I like to think about it like cattle trails. If you've ever seen a field where cows are walking up and down and they're creating these different trails, our brain develops like that. So the more often that we jump down into this survival mode or emotional brain or these different responses, fight, flight, freeze, for example, then the deeper those pathways have gotten. There's a really common phrase, the neurons that fire together wire together. And so the more often we jumped into those parts of the brain, the deeper those grooves or cattle trails have become. But the beautiful thing about our brains is neuroplasticity, our brain's ability to adapt and to change these pathways and what parts are activated and more engaged in our daily life. And so the more often that we can practice tools that are creating new pathways in this upper region of the brain, these somatic practices, brain games, mindfulness exercises, yoga, etc., right? Ways that we're completing our stress cycle and starting to build new pathways up in this upper region of the brain. So that ideally, the more that we're practicing these tools, when our amygdala starts to fire and we're about to flip our lid, we might flip our lid for an hour and be dysregulated rather than the entire day. Right, so we're able to put our lid on faster, right? Or maybe even keep our lid on in a situation where we might have historically flipped our lid. And so even though these parts are not a muscle, I really like to think about them like a muscle. So the more that we're practicing these tools, the more that we're strengthening this part of the brain, strengthening those neurons that are firing and wiring together so that we have a different response and a different way to put our lid back on. And I really love that phrasing that he uses because I would much rather have somebody talk to me about, oh, I had a flip my lid moment, right? And we just make sense of it. We understand it. It's a fact. We flipped our lid. We learn ways to put our lid back on rather than more of a self-shaming statement about what we did when we flipped our lid. So my goal is really to try to take the shame out of trauma and to understand what's happening to us mentally and physically, so then we can work with that system.